Hello, everybody. We have just opened the door for you to connect. Welcome to Digital Ship webinar on how AIS data can be used to improve vessel performance. We put forward the case study of exactEarth and vessel performance solutions from Denmark working together. I'm happy to introduce you to our speakers. Please meet Bruce Winter, Director of Product Management with exactEarth, and his colleague Lasse Urs, Sales Director. And finally, Jakob Boos Pettersen, Director and co-founder of Vessel Performance Solutions from Denmark. Anytime during the webinar, please submit your questions via the Q&A box. And we are starting off with Carl Jeffrey, founding editor of Digital Ship, giving us a bit of context what AIS data is and its usage. Let's go.
So we're going to talk about using AIS data to improve vessel performance. So I'll start very basically. If you're not familiar with AIS, these are automatic identification systems, radio transponders, which all ships carry, which broadcast data about the ship's position every few minutes. And the data is sent by radio signal, and they can go very long distances, but they only go in a straight line. So that's quite important information to get around for the next point. So these data can go to radio masts on the ground. That's the way we've been doing it since about when we started in about 20 years ago. But because the Earth is curved, there's a limit to how far they can go along the Earth's curved surface. So you've got to have radio masts across the whole oceans if you want to get a whole world picture of AIS data. But using satellites, the AIS data can go up to a satellite. It's got to go much further, so maybe 700 kilometers to a low Earth orbiting satellite, but you can gather AIS data for every ship is ever transmitted anywhere in the world for every single ship in the world. And one of the companies which is gathering worldwide AIS data, exactEarth, is going to speak today. So companies are starting to look about how we can use this for vessel performance. So we're getting a position every 15 minutes, which may sound a bit low resolution, but it's actually much more granular than what ships often have, which is just a noonday report saying where the position is and what the tank level is. And you can get a lot of errors in the noonday report. The AIS data is automatic. And even if ships are providing other sorts of data from automatic loggers, the AIS data can complement it and check it. So we've got two parts to the presentation today. First, we're going to hear about how we're gathering AIS data for the whole world. And secondly, we're going to hear about how to use it for vessel performance. So the first part is given by exactEarth. That's an AIS vessel tracking company based in Ontario, Canada. And we're going to hear from Bruce Winter, Director of Product Management in Ontario, and then Lasse Urs, who's the European Commercial Director in Copenhagen. And they're going to tell some stories about how they work with customers. And then we're going to hear from Vessel Performance Solutions, which is a vessel performance company in Copenhagen. And we're going to hear from Jakob Boos Pettersen, Director and co-founder, who's former Director of Energy Efficiency with the Class Society ABS and Head of Vessel Performance with AP Muller since 2002. So he's been doing vessel performance since well before most of us had ever heard of it. And he's going to talk about how AIS data is used to build performance models of the ship to support better decision making. So I'd like to invite Bruce and Lasse to give their opening talk. Thank you.
Thanks, Carl. Hello, everyone. Thanks for joining the webinar again. And I want to maximize the amount of time we have for Jakob and any Q&A at the end. So I'm going to dive right in. So just to give you a bit of a background about exactEarth, if you're not familiar with who we are, we're a Canadian company that was founded about 12 years ago. We were one of the early innovators within the satellite AIS vessel tracking business. Our mission was fairly simple, is just become a global leader in AIS vessel tracking services. Initially, when we launched, our customer base was almost exclusively the government agencies. They needed information about extended details about where vessels were entering their waters, what ports they had visited, or maybe mid-ocean kind of odd behavior that would drive them to kind of further investigate those vessels coming into their waters. So from those early days, our customer base and our satellite services really have grown significantly. We're serving over 1,000 government and commercial customers now, utilizing about 70 satellites with also some very foremost partnerships with terrestrial AIS partners. So AIS vessel tracking services really have become a primary tool for decision makers in the maritime industry. Why is that? Well, for a lot of reasons, but some of them revolve around the fact that the AIS adoption really has grown from about 0 to 600,000 vessels in about 10 years. It delivers a lot more than just the vessel's location, delivers the ETA, draft, destination, and some other information, and also minute-by-minute updates when a vessel is moving. However, really until recently, when vessels were out of that coastal range, the line of sight, reliable and persistent vessel tracking was really quite a challenge, given the gaps in satellite coverage, or just the length of time that it would take to downlink AIS messages from the satellite to the ground. Ultimately, AIS customers needed consistent minute-by-minute updates if they were going to use AIS as the foundation or the building blocks really for their platform or analytics. Well, exactEarth solved that problem a couple of years ago. Our real-time service is generated using 70 satellites, kind of pictured here in the image. And they utilize what's called a mesh network. And so they allow each one of the satellites to communicate with their neighboring ones. And it results in a live real-time vessel updates anywhere and everywhere in the world. We track about 250,000 vessels every day and deliver more than 50 million updates associated with those vessels, really all within seconds of the vessels transmitting the messages. So it does provide a very good foundation of real-time vessel updates. So how does this real-time persistent coverage translate into what a vessel transmits and the vessel updates for ship tracking? I took a screenshot yesterday of a random vessel transiting through the South China Sea, the Falcon Trader. And as some of you may know, getting minute-by-minute updates in this region of the world is a real challenge, given the density of vessel traffic and vessels transmitting AIS in this region. But so over the past few days, though, the longest gap in coverage we see for a vessel like this was just a few minutes. And so if your vessel tracking requirements need this kind of frequency and quality of vessel updates, then you may want to take a closer look at our services, the real-time services that we offer. Before I pass the presentation along to my esteemed coworker, Lasse, I just wanted to reiterate the fact that really any kind of tool or analytic decision-making platform needs to start with a solid foundation. And that has proper checks in place, quality checks in place, with an emphasis on really providing the data you need, however you need it, in whatever formats you need. And that's really what exactEarth has focused on. It's what we do, and it's how we enable customers like JPL to be able to do better for their customers. Lasse, I'll hand it over to you.
Thank you, Bruce. Hello, everyone, and glad to be here and glad to see that many have joined. Again, thanks, Bruce. Thanks for the good explanation of what we do, and thank you for the build-up. I'm not planning to go into further details on my background, but I I do want to say that together with my good colleagues in the sales and commercial department, we are sort of the customer-facing arm of exactEarth, right? And echoing a little bit on what Bruce said, we are the data foundation, right? We are the data vendor of AIS Data, and we collect the data, as Bruce mentioned, from our unique constellation of satellites, and we database that and take that and deliver that as a service towards our application partners and end users. And as you probably already know or can imagine, this vessel positional data has today many different applications within the maritime industry or segments that are within the maritime industry. And it's also one of the building blocks for many of the maritime analytics and services that you see in the maritime industry today. And even though that we can deliver real-time tracking and 1-minute updates of the AIS tracking data, that doesn't necessarily mean that that is what you need. It all depends on your use case and your business case, right? So with this, we need to work together with our customers and application partners in order to find the best data service, AIS data service for them and their business case. And just as we did with VPS some years ago when we first started talking, we sat down, we had a good talk on understanding what is VPS, what are they doing, how are they intending to take in the data, and what are they intending to deliver and derive basis this AIS data set towards their clients. And with this dialogue in place and let's say this understanding in place, we could then, let's say, deliver the best data service for VPS. And that sort of applies to all our customers that we work with today. A different customer, different focus and different use case. And as Bruce mentioned, we started out with the government industry. We have then moved on to the commercial industry. We are in the NGO space, we're in the Navy space. And again, that means that there are many different use cases of this data, as said. We have mission critical operations who use the data to simple vessel tracking that also utilize the data. And all these have different use cases and needs basis the data. If you're a search and rescue company, you need live data. If you are AI powered analytics firm, you need frequent data. If you're a commercial vessel operator, you maybe need less frequent data. And if you're a small vessel owner who just want to track your 5 vessels out on TC, then potentially 2 updates per day is more than enough to solve your need, right? So it just goes to show that with all these applications within the maritime industry, there is no solution that fits all. And it all is sort of say grounding in a good first initial discussion and understanding of the business and the actual use case of the AIS data. And throughout the years, and Bruce, maybe if you go to the next slide. Throughout the years, we sort of have, let's say, heard and analyzed that there is 3 common requirements from all our customers. Data quality is the first and foremost, and that's sort of a given. And it's also our commitment to the industry and to the market. We do and we will continue to do our utmost best in capturing and delivering quality AIS data to the market, not only from our constellation of satellites, but also, let's say, through internally and the processes that we have internally, these processing checks that we have to clean the data before we deliver it to our customers. And secondly, reliable data delivery and flexible data access. If you as a customer is relying on quality data and data for your service, then you also need to be rest assured that the data that you're purchasing is up and running 24/7, and that you can access that in a flexible way or manner, so you don't have to reconfigure your backbone in order to understand and digest the data. And then you would say lastly, and equally important as the 2 others, support. We are talking big data here. We are talking billions of data items that is not always easy to understand. It's not easy to store. It's not easy to analyze on. So we encourage and always have a good let's say post-purchase or post-process dialogue with the customer, not only to set it up, but also on a continuous basis to follow and maintain the dialogue to make sure that it's working now, but also is continuously working in the future. And with that, I think that sort of quickly sums up the presentation of exactEarth and what we do within the maritime industry and what our bread and butter are in the maritime industry. With that, Jacob, over to you on VPS and what you do with the AIS data.
I'm trying to get to a situation where I can share my screen, but I think it's coming up now. Thank you very much, Lasse. Yeah, hello to everyone out there, friends, colleagues, maybe even potential clients, whoever is here to listen in. Happy to join you on this Friday afternoon. We will tell you a little bit about how we utilize the AIS data that we are getting from exactEarth. But it's not only that, we will also try to convey a little bit about what is our philosophy behind what we are doing in performance management. And it's very much a question of that we get a lot of data. Data quality is an issue, precision of the data is an issue, and it's not always very precise what we are getting. So any type of more precise information, more accurate, better data quality that we can get our hands on improves our ability to actually improve on vessel performance predictions. Not only predictions actually, but also simulations. So if we take a broader picture, then I think I thought it was a good idea to start with the digitalization roadmap. So basically, we are subject matter experts in our small company here, and we are true believers that if you want to do advanced analytics, then you need dedicated systems to actually be able to do that. That is why we are also, again, we are a small company. There's a limit as to how much we can do. But we also truly believe that the future lies in that there will be several types of expert systems within different areas. But in the future, these different systems will have to be able to speak to each other in a smart and intelligent way, so that the end users, they experience a smooth user experience and not having to open and close and compare results in different systems, but they actually get the right information in the right system. Of course, when you talk about interfacing between systems, then everybody will immediately say, oh, but that's very complex, and we have to make standards for this and that. And that is, of course, always true. But our experience, we are doing interfacing to many different systems on a daily basis, so I think it's just our experience that if you do advanced analytics, then it's very seldom that you have a full data set from anywhere. You will always have to mix data together to get all the information you need before you can do your analytics. And that is what we do in Vessel Performance Solutions. It's one of the things that we are doing. We are integrating with a lot of different systems that our clients are either using, or you could say one thing is we are getting information from clients or from exactEarth or from other sources. And then we are also delivering data to other systems as well. So we are interfacing on a daily basis. And I think that is a very important part of digitalization going forward, that is the interfacing. And then when we then talk about the future of digitalization, Internet of Things, well, our interpretation of that is very much that we try to collect the best data from whatever source is available out there, and then combine it in the best possible way to provide the best possible decision support for our clients. So when we set out to develop our performance management software, Vessel Performance, we call it Vesper, then of course the first thing that we have to realize is that we are trying to establish advanced algorithms that can model the whole ship and the environment in which it is operating. So it's a very complex system. It's not only complex, but it's also highly non-linear, and all the effects that impact the ship, it's almost impossible to describe all the effects actually, but nevertheless, that's the system that we are trying to identify. On top of that, we also have the situation that the data that we are getting from the ships, or the design data from the ship, may not be accurate or whatever. There are so many uncertainties in the data that we are getting that it's obvious that this is a very difficult thing to work with. And I think it's one of the reasons why people start out often saying, oh, we build our own performance system, and that's fine. But I don't think they are really aware of how complex this system actually is. So in order to handle this, I come from the modeling world. I believe in physics and first principles, and we do that in Vessel Performance Solutions. So our approach is the model-based approach. We believe in physics and first principles first, and then we look at the data after that. And then when we have the model of the ship and the environment, then we compare the performance of the vessel with the expected values. And that's how we then calibrate our mathematical models against the operational data. Some people tend to move in the direction of artificial intelligence, and that is absolutely possible. In the modeling world, you talk about black models and white models. The white models is a pure model-based approach, and the black models is a complete black box. I think everybody's working in some area between those two extremes, but I think it's fair to say that Vesper is then in the light gray category. We are more towards the white models than in the black models. So more specifically, the type of data that we are moving into is ship design data, sensor, event, operational data. And then, of course, we have positions, hindcast, and charter party information. All this information goes into our modeling capability, so to say, which is the mathematical model of the ship and the environment. And then, of course, combined with what we think is, at least to our ability, the best possible analysis of what we can do. And then we provide the decision support, which can be all kinds of analyzed results, aggregations for fleets, performance indicators, key performance indicators, all kinds of data validations and advanced diagnostics. On top of that, our calculated results, decision support is further available for our clients or whoever needs that type of information and can be accessed through APIs as well. And of course, as a part of this is the feedback loop. So if people then make decisions based on the output, then the typically, mostly, of course, the operational data and the event data will change. And then we have a continuous loop of optimization here. That is how we do things in detail. And everybody can hopefully, I don't know. In our world, this is a very complex environment we are working in with a lot of imprecise data. And for that reason, we have joined in the Shipping Lab project because we know it requires a big effort to see through all these uncertainties and improve our modeling capabilities. So we are in this Shipping Lab project called Digital Ship Operations with a subtask of a vessel operation, where we work in these 4 different areas. The digital twin, improve our vessel performance predictions, with the purpose of being able to, of course, tell people or our clients, what is the performance now and what will the performance be in the future. I think especially the last part is going to be a very important part of what we are all going to do in vessel performance in the future, among other things because of regulations. Then a second task is that we want to improve our voyage simulations. So we all know that in vessel performance, it has traditionally been so that we don't really care about the performance in the bad weather because we just filter it out. But we are not going to get away with that in the future. So we are going to improve our capabilities for the digital twin, predicting performance in also the bad weather conditions. Another task is involve the vessel crew in performance management. And the crew, for that we develop the crew feedback module, and then we try to help our clients on advanced diagnostic sides. The partners in the project are Lauritsen, Bolkerstorm, BV Epic Kosan, Hapag-Lloyd, Technical University of Denmark, University of Southern Denmark, and Svendborg International Maritime Academy. So this is a project where we are spending a lot of resources in, all with the purpose of improving our predictions. And of course, then the use of precise information is a key element in this. And here the AIS data comes in very, very handy. First of all, we get the AIS data with a much higher frequency than what we get from the noon reports. We can look up at the AIS points with the correct timestamp. We can look up hindcast, wind, waves, and ocean currents. We have a cooperation with WNI where we are doing that right now. But in principle, we could look up the hindcast data with any weather provider. You can do a lot of stuff with the AIS data. To the right, you can see an output from our map function. And what is interesting here is not, I mean, everybody can plot the AIS points on a map. And you see them here, but you can also then see the corresponding weather that we have looked up in the hindcast weather on all the AIS points. You can see also the noon reports in the plot with the corresponding weather as reported by the vessel. And you can see the position of the noon reports. But what is maybe even more interesting here is that you can see the AIS points ahead of the last noon report. So we have the latest information from the vessel which will always be updated with the frequency with which we are asking exactEarth for that information. But on top of that, you will also see the planned route as received from the weather routing company. In this case, it is a W&I route, but we also interface to other weather routing companies. So in the map, you see the noon report, you see the AIS points, you see the hindcast weather, and you see the future plan for the ship, all including the weather information. So this is the type of information we can use to enrich and actually have more confidence in the data that we are receiving from the vessels. And this is of high value because every piece of information that we are getting, in principle, we need to double check and maybe even triple check if that information is true or not. And here the AIS points, of course, come in very, very handy. So what is it that we do? Well, basically, this is a plot showing our analysis for a vessel and doing the trending of the performance of the vessel. And you have seen plenty of these plots in the past, and everybody has their own way of doing that. But in this case, I would like to just ask you to focus on the last period here, because you can see that in the last period, there's a dry docking here, and then we have like 7 reports after the dry dock. And then the shipping company, they're of course very interested in understanding how good was this dry docking. Was it a good one, a bad one? And our main aim here is to reduce the scatter so we can tell the performance of the vessel as quickly as possible with as much accuracy as possible. So we want to improve our modeling capabilities by reducing this scatter that you see in a plot like this. But the thing is, before we actually even start thinking about this, we have to establish a measure for how good is our trending actually. And that is kind of depicted in these 2 graphs here, because they show the 95% confidence interval for our prediction of the added resistance. The upper plot shows the prediction using the reported weather from the vessel, and the gray area there is actually the width of the confidence interval. And then the plot in the lowest plot shows you the same confidence interval, but in the case where we have been using the AIS hindcast data to calculate the weather impact. If we then again focus on the last part of the period here with only the 7 reports, you can see that the size of the confidence interval is much bigger than actually the height of the confidence interval when we are using the AIS hindcast data to compensate for the weather impact. And in fact, it's almost half the confidence interval by using the AIS hindcast data. And that is a significant result in this particular case. So here, I mean, everybody who's out there can easily see that using AIS hindcast in predicting the impact of the weather on the ships is a huge advantage in this particular case. We can say in general, it is a huge advantage, and we are using it as a standard in our service today. But this is not the clue from our perspective of what we are trying to convey here today, because that is AIS hindcast, and that is just great. But of course, in everything we do, we try to use the same method to actually quantify how good are our predictions. So this comes to when we get the noon data, when we talk about it, for example, especially the speed, but also is torsion meter better than fuel for estimating the power. And of course, we can also quantify what is the effect of using autolog data on top of this. On the weather side, we have waves, we have wind, we have ocean current. We are also able to play around with these parameters and maybe comparing different sources of this type of information, and even quantify which one of these 2 sources is actually the better source. And in that way, we are going around, you would say, with all our different data sources and all the time trying to quantify which one of these data sources is the better one, so that we can continuously improve our predictions. So this is our philosophy of how we are working with AIS data, but not only AIS data, it goes for any data source that we are using for our calculations, all the way, always trying to quantify whether this or this source is the better way of doing things. Not only the source, it can also be algorithms or methods or added resistance in waves, whatever. with this method of quantifying how precise we are able to find the better sources. And I think that's ends my presentation. Thank you very much.
Wow, well, thank you very much, Jakob. Okay, well, we're going to the Q&A session of the event. If you'd like to stop sharing your screen, and if I'll invite people to open the Q&A box, we'll already see four or five good questions on there. And Lasse and Bruce, if you want to turn your cameras off, I think maybe I'll give the maritime questions to Jakob and the AIS questions to Bruce and Lasse, but let me know if that's wrong. But I guess we start at the top of the list. So Gürkan Büyüktelli, I'm not very good at Turkish translation, but he's with Merck and shipping in Istanbul. He's asking on the additional workload on the crew and the company, but I would have thought this for Jakob. I think there's no additional work. The AIS is automatic and your service is not done by the crew and company, it's done by you. Is that right answer?
Well, it depends on what type of service you sign up for.
Oh, your camera's off, Jakob. You want to turn it on? Oh. Do you want to turn your camera on? There we go. Very good.
There we go. Yes, thank you for the question. Basically, our service runs without any additional work for the crew because we typically take the data that the crew is already reporting. But at the same time, we have as an additional service, we have a crew feedback module which works on board, where the objective of that crew feedback module would be to get the crew involved in the process and have an interactive dialogue where the crew is seeing the same data as you see in the office and so on. But that is, yeah, an additional service that comes on top of the original service, which, but as I said, yeah, it doesn't require any additional work for the crew.
Okay, I don't see any questions on the AIS service for Lasse and Bruce, but maybe I'll ask one of my own. Well, what are you actually offering then? So you've got a global database of all the AIS data, every ship is broadcast, and that's available as a commercial service. Is that? Because that's a wonderful thing, to get people thinking about what they can do with it, isn't it? I think it's
correct. I mean, as said, what we offer is data, right? Data as a service, and one could say that only the imagination sets boundaries for what you can do with this data. Mildly put, right? So basically, this is raw data and positional data from all vessels that are sailing the world sea or the global sea.
So every shipping company who asks for a noonday report from their ships, which is every shipping company, they're far better off using your service than the noonday report, because the noonday report can have inaccuracies and yours is automatic. Is that fair?
Yeah, but you can also say the noon report provides a lot of additional valuable information, not only in regards to position and so on, right? Jacob cannot do his analytics and his analysis only on AIS data. He needs engine information, vessel information, and so on. So one doesn't exclude the other.
Okay, so if we go to Jakob, maybe we'll take these first two questions together. On Victoria's question, do you do voyage optimization? I think you don't, but the raw question is more quite interesting.
Wow.
Oh, you're sorry.
Questions. We will answer.
You want to take that one? Then you do voyage optimization?
So which one is that?
Right at the top of the list there, Vittorio. So it's when you plan out a route for a company, or they say, I want to go from here to here.
It is a part of our shipping lab project,
Okay.
but it's not a part of our, you could say, service that we are offering right now, but it will be in 1 year from now. It will be an integrated part of that. But I would say also that yes, the optimization of the voyage from a commercial perspective, we definitely offer that. But the weather routing in itself, we would rather leave that to the weather routing companies, because they have these 30 years of experience in doing this, and it's a lot of responsibility. There's a lot of safety in this. We are not experts on that, but on the voyage optimization itself, we expect to become real experts. And of course, the reason why we expect that we can make a difference here is because we are constantly improving our digital twin with a structured way of doing this. So we are quite convinced that our simulation model will become better and better as time goes by. And of course, then the simulation of the voyages and the optimization of the voyage itself from a commercial perspective will become a part of our service. But right now, we are not able to deliver that service, but we will.
Okay, so Roar Adland is a shipping professor at Norwegian School of Economics in Bergen. So he's asking, if you're only getting fuel data once a day, why would you want high frequency weather data or high frequency position
but that's
data?
a good question. That's a good question. But the thing is, it's a good question, but the answer is so lovely because it's a very clear thing we can answer to that. The thing is that during the 24-hour day, the vessel will have a certain average speed and it will vary during the day, but the weather will also vary during the day. And the thing is, if we can have the variations of the weather during the day, then we can also calculate the impact of the weather integrated over the entire noon report. In that way, we can get a much more accurate calculation of the impact of the weather on that particular day than if we just had that one observation at the beginning of the noon report and at the end of the report. Here we have the whole variation, and we can therefore take that into account. And actually, that improvement in confidence interval that you saw in the slide before of the confidence interval becomes half as high as that. That is only due to that single effect, actually, that we are able to integrate the impact of the weather much more correct than just using the endpoints of the noon report.
Okay, so if we go to row Earth, I don't actually understand the question. Did you say something about filtering out bad weather, which I missed? He's asking if you filter out part of the route. I don't know if you understand what he means there.
That's a very difficult question to answer. It's almost a PhD project. Again, a very good question. The only thing I can say that our standard filters are that we include up to and including Beaufort 4, and then we filter out Beaufort 5 with the methods we are using traditionally. But in the Shipping Lab project, where we are enhancing our method, we expect to go up to Beaufort 5, Beaufort 6. But basically, again, our philosophy of this thing of quantifying how do we get the best confidence interval, that is what will decide which weather conditions we can actually include in our model. So basically, to answer that question today would actually require a big study to be able to quantify that. And it's, by the way, a very interesting study that we would like to have the time to do, but yeah, we have to prioritize.
I guess a model can be very simple and very complicated. There's no limits or controls on either side. Yeah, okay. So I think Doug Holden's question is more for the Lasse and Bruce. So he's asking about validating AIS data. How do you check it? I suppose it's like rules that companies give out the right number. I'm not sure what MMSI number is.
So yeah, two questions here. So the first one just asking about the validation of the data. So we will actually have a few different services that some of our services provide just the raw data that is entered into the equipment on board. So there is no validation, and we do that intentionally because there are customers that want to see the raw outputs from what's coming from the vessel, and that includes whether it may be draft or ETA. Hopefully they're not broadcasting the wrong IMO, but we do also have other services that look at the draft and ETA, look at changes in it, look at validating those services. So we offer both, and sometimes we'll lean on some of our terrestrial partners to be able to assist us with some of that information, some of the validation. And in other cases, especially in the government market, they do not want any manipulation of the data. They want to just see the raw data. As far as how our records are indexed, they're not by IMO because only Class A vessels broadcast IMO. So if it was done by IMO, then we'd be missing about half the population of what broadcasts AIS data. So it is by MMSI. We also have, again, other partners who introduce a further index value. So there is a problem in sometimes when people with slippery fingers maybe enter the wrong IMO or enter the wrong MMSI, and they have duplicate values. Some vessel in the North Sea is broadcasting the exact same values as a vessel in Australia. that can present problems for some of our customers. So we work with our partners to deduplicate that, and that's one of the ways that another validation that we offer to be able to try and correct some of the manual data entry problems that exist.
Okay, so I think we're going to Jakob now. So Olli Nielsen is the CTO of Navidium in Finland, which is a IT systems and services company for shipping. How accurate vessel model can you create? I think you kind of the best answer to that was a slide you showed about how accurate it is with their AIS together with Hindcast.
It's actually in this particular example, it was a 50% reduction in the confidence interval, so twice as precise in this particular case. But it will of course vary depending on how many reports you have. But the impact will of course be bigger in the beginning, because as you get more and more data coming in, then of course the scatter becomes less and less important if the trend is the same. But in this particular case, it was a 50% improvement in the confidence interval, which is quite significant.
Okay, so if we go to Assen's question, Jakob, I just looked at Assen's LinkedIn page. He's a vessel reporting and performance control and support with V-ships in Hamburg. So he's asking, how do you motivate the crew to take care of proper reporting? But I think your approach maybe is to get around that. We're not asking them.
Yeah, but the thing is, in our crew feedback module, what we are doing is that we are showing statistics of the problems that are in the reporting from the specific vessel. So the vessel will get very precise, transparent information about the problems that are in the data that they are sending to the office. That's one side of it. So that should, in principle, be self-motivating, because you are actually being told in a transparent and a straightforward way what are the problems with the reporting you are doing. But the other part of it is that then when we quantify vessel performance, then in the crew feedback module, we are actually benchmarking vessels against sister vessels. So our hope is, of course, that when you do the benchmarking, you can see that there are other vessels out there that are performing better than your vessel. Well, then you can either say, oh, I don't give a shit, and say the others are stupid, or you can take up the challenge and see if you can improve on your ship. Here, of course, the actions from the office are very, very important, because this is all about knowledge sharing. And you could say, if somebody is doing a good job, then highlight that and tell, how are you doing this job well? So, and distribute that to everybody so that the whole fleet can benefit from that strategy. So that's how we try to do that.
We've got a great question now for Lasse and Bruce. So this one comes from Bob Ball, who's an electrical superintendent at BP Shipping. We've had issues with suppliers, I think he means AIS data suppliers, refusing to supply us due to apparent gaps in AIS tracks. How frequent are these gaps, and are there certain parts of the world more prone to this than others? So I suppose that must mean ships in some parts of the world switching their AIS off, which I guess we can all guess which parts of the world it might be more likely to happen. Are you able to answer that one?
Yeah, I can take a stab at it, Lasse, if you want to add afterwards. So certainly there are parts of the world that are more difficult to detect by satellite, and that's just in the areas of high density, like the South China Sea, and off maybe the coast of China, where it's outside of terrestrial range. It's one of the reasons why we introduced our vessel-based AIS, what they use in that case, they actually use vessels that are transiting the world, and they aggregate all of the AIS messages they detect from their surrounding vessels. So it's a supplement to the terrestrial coverage. It's a supplement to the satellite coverage. And in that service, there really are no regions of the world where we have any significant gaps. Might be a 3-minute or a 5-minute, the way I showed the example that I had. But the gaps themselves are not coming from gaps in satellite coverage, because we always have persistent satellites on overhead. It just may be to do with weak transmitters, improperly outfitted transmitters, or Carl, as you said, sometimes they turn them off. Vessels will turn their AIS off. Sometimes it's by accident, but we also see that there are parts of the world that and certain types of vessels that want to be obfuscated and maybe don't want their location being known. And more often than not, those are fishing vessels. They may have some special fishing grounds that they don't want to tip their hat to others. So in those cases, we will see vessels shut off their AIS for periods of time and then come back on. And it's a regular pattern that it's certainly not something that we would ever want to endorse, because that obviously makes it a lot more dangerous, given that AIS was originally introduced as a collision avoidance system. So it's certainly not something that we would ever want to happen, but we do see a very, very, very small percentage doing that, like in the kind of 0.5 or 0.1% of the vessels that do broadcast AIS.
There's a capacity limitation with this SOT DMA, isn't it? You split a second up into blocks, is that showing me?
Yeah, I mean, the capacity has to do with the number of channels that are available. It's a self-organizing AIS organization. So the fact that they're talking to the vessels around them, they're picking the different slots of when to transmit. But yes, when you have too many ships in one region, then you will get overlaps in those slots, and it does become more difficult, or the messages become jumbled. But it doesn't happen that often. It was fairly future-proofed. So the 2048 slots that are available for broadcasting, they're not too often overrun from the terrestrial providers, from satellite. Absolutely, we might see 60 or 70,000 vessels transmitted at one time. And we have some technology that decouples all of those. But we also rely then on our vessel based AIS, as well as the terrestrial partners, to assist in detection of those.
Okay, and then just to add quickly on yours here, Bruce, right? As you mentioned, right, our satellites are in this mesh network here. So, for example, in the open sea, if a satellite tracks a vessel or a specific group of vessels, right, there will be no gaps of getting the data from those, because the satellite is then connected with its neighboring satellite in order to share the data and send the data to the shore side. So with our constellation of satellites, you won't be seeing these types of data gaps that you could potentially see in let's say, traditional data satellite data constellations.
Oh, sounds great.
That is also assisting to that, you can say, of minimizing data gaps.
Excellent. Okay. So a question here from Novena Pierce, who I just looked on LinkedIn, is based in Halifax, Canada. And she's asking about quality of models, and also Mikhail Moutsouris is asking about models. Maybe go back to Jakob for these. So if large variations occur in speed, how do you validate the accuracy? And Mikhail is asking, as a vessel gets older, because it's got or has had bad maintenance, the state of the vessel gets older. I suppose the answer is your models update all of these if you're able to. Is that I don't know if you can.
I think it's two different questions, because I think the first question is about if let's say the vessel is drifting for 2 hours, and then you could say we only get the average speed and so on. But again, here the AIS data can easily pick that out and compensate for that. On top of that, the variations in speed, they can also happen because of currents are changing, or the power is changing. But in general, if you are only working with noon reports, then that will be difficult to catch because we only get that one fuel measurement or power measurement per day. So we are not saying that that problem is fully solved, but the variations in speed can be handled from the AIS points. And then what can you then do in those cases? Well, basically that report would be filtered out, because it would be considered outside of bounds of what we normally do. As regard to the last question there, it's about modeling accuracy. And yes, our models do take into account that, let's say the vessel is heavily fouled and it goes into some severe weather, say for 8 head seas, and then suddenly the vessel simply cannot move forward because it's so foul that there's not enough excess power to go against the wind and the waves. Yes, our model will be able to catch that. because we have you could say, the implementation of the engine diagram and the RPMs and all that. It is a part of our model. And this is something we are working on. I wouldn't say that it's ready right now, but that's the part that we are working on in this Shipping Lab project, because this is, of course, a very important part if we want to simulate also in bad weather. And this goes, the difference between a clean hull and a very dirty hull is, of course, enormous when you go into the bad weather. And that is what we are working on to be able to simulate that in both situations.
Oh, very good. We've got a lot of questions about AIS technology on board the ship, which I'm not sure is any of your sort of field of expertise. So feel free not to answer. So Roar is asking, does anybody know about how much companies are wrongly reporting their draft values? And then Elsie is asking, do you recommend any device that's other than a ABC Class B transponder? I don't know if you want to any comment on those, or maybe we'll just.
Yeah, I think in terms of the number of the amount of incorrect data, I would say it's much less about incorrect data. It's just data that isn't present. So AIS, when there's no value present, it transmits default values, and I would say that would be the lion's share of also incorrect data. I think for the most part, vast majority, probably 95% of the time, if the crew is taking the time to enter the data, whether it's ETA or destination, draft, that the vast majority of the time that it's correct. What they will do sometimes is take some liberties about, say, destination, and it might be Shanghai, but they use the various short forms for that. So again, we have some partner offerings that are able to distill a lot of those short forms down into kind of a concise, more industry standard destination. And the ETA, for items like that, it's usually pretty obvious if they maybe haven't updated it since they've left port because it's in the past. And again, some of our partners offer solutions that have more calculated as opposed to what's just been entered into the AIS. And some of those calculations use ancillary data sets to be able to determine, predict where it's going and when it'll be there. So there are mitigation strategies to augment some of the invalid or incorrect data being entered into the AIS.
Well, should we go to Aslan's question, Jakob? So Aslan from V-Ships in Hamburg. So I guess he's asking, how can you be sure crew are providing the fuel consumption properly? You're the expert on the noonday reports. I know we've talked about this a few times. I guess it's it sounds like simple stuff compared to this fancy technology, but I guess this is where companies are having the most difficulties, aren't they? I guess just getting.
Yeah, it sounds simple, but it is not so simple, and that's also why Asian is asking the question. But of course, I have to accept also here that half of the people who are listening in here, they are our competition, right? So a little bit of a secret I will like to keep to myself. But we are having many different ways of doing that, but one of them is quite obvious, and that is that you are all the time keeping track of the ROB numbers, and then you are comparing the ROB numbers with bunkerings, and making sure that what is disappearing in the noon reports actually also matches the amount of fuel that is bought through the bunker delivery nodes. So that is a kind of a straightforward, not very secret way of doing that. But we also have other methods, and we are even developing further, I believe, a very, very strong method to be able to do that in the future as well. But I don't want to go into the details of that. But it is let me put it in another way. It's not impossible to figure that out with today's technology, and we are expecting a lot of improvement on that on top in the next 6 months or something like that.
So Aslan, if you'd like to contact Jakob after the event privately, you'll get a more comprehensive answer. Is that another comment? What if ROB is also wrong calculated? Anyway, we'll move on to a.
But you do still get the bunker reports. So if the ROB is calculated wrong, then you can still see in the bunker reports how much fuel have they actually bought. Then you can argue, okay, the bunker reports can also be wrong, but I mean, you can do a lot of stuff also automatically.
Okay, so Lasse, you'd like to answer Bruno's questions. I looked at Bruno's LinkedIn page. If it's the same person, he's a cybersecurity expert in maritime in Paris. So he's saying, I've seen studies that show satellite AIS only get 10% of the messages. So, okay.
Yeah, I think I just wanted to make a short comment on that one, and Bruce, you can correct me if I'm wrong here, but correct, yes, I don't know about the numbers, but yes, correct. We also the satellite also detect AIS messages in dense areas. We just don't do it as, let's say, frequent as the let's say terrestrial device or antenna that is closer to the actual vessel, and then you can say if the vessel itself is able to transmit message 27, then with our constellation, it will also be, we will also see the vessel more, let's say, clearly and receive more messages from the vessel.
Oh, that's
I don't know if you want to add to that, Bruce.
Yeah, so this was the message 27 was actually designed for satellite detection. It was part of the AIS spec that was updated in 2015 or 2014, launched in 2015. So the first transmitters started to show up then. And for the last 6 years, about 45,000 ships have updated their transmitters or new vessels that have this capability. So they transmit these messages much less frequently. So it's a higher likelihood of getting detections. They transmit every 3 minutes. And we have extremely high rate of detection, almost 100% detection of each one of those messages, even in areas like the South China Sea and the Med and the North Sea, where there is huge amount of vessel congestion. Prior to that message 27 being available, we would have had great difficulty detecting the majority of the ships. But I would say the adoption of that technology, that new technology, makes it much easier for us to detect in those difficult to detect regions.
It sounds like a few people have tried this before and the technology hasn't worked, but the technology has improved. So maybe that's an important message to get
Exactly.
across.
Yeah.
Okay.
Yep.
Okay, well, we're coming up to the hour now. There's a couple of interesting questions for Jakob here. Maybe you can give a short answer. So Jacob or Jakob Tan is asking, can you model vessels powered by alternative fuels? I suppose the fuel consumption, I don't know what difference that would make.
It's a good question. I think, first of all, today I can say that we have LNG vessels in our service that are running on LNG. So from that perspective, yes. But basically, with all our analysis, what we do get, because you have many different fuel types today, and the thing is that the calorific value of those fuel types varies a lot. So basically, we either, if we get the fuel type, we assign a default calorific value to that fuel, but a lot of our clients are actually, together with the amount of fuel, they also deliver the actual calorific value of that fuel in the data we are receiving. And then we are, you could say, taking that into consideration in our analysis. So yes, you can bring methanol, ammonia, etc. We don't care, but please provide the calorific value.
Oh, do you want to give a quick answer to Ulrich's question? He's a defense consultant. He's asking, do you take into account the wavelength of seas, which make the North Sea different to the Baltic Sea? Answer, yes, you do.
And the North Atlantic? Well, I would say it's a good question. I would say in the method we are using today, traditionally, no, we are not. But in the method we are implementing as we speak in this shipping lab project, yes, the period of the waves, the actual wave spectrum will be fully taken into account.
Oh, that's fantastic. Well, we're coming up to the end. Maybe as our sponsors, Lasse and Bruce, do you want to take 1 minute to give maybe for Bruce to give a sort of last word you'd like to leave the audience with as we go off for the weekend?
Yeah, I just wanted to thank everyone for joining. We really appreciate your time, especially for most of you, or it's Friday afternoon. So really appreciate it. And we're very open to hearing any more questions that you have. So please feel free to reach out to us directly or to the info@exactEarth.com site. And yeah, appreciate your time. And thank you, Jakob, for all of your efforts. Really appreciate it.
Thank you.
Oh, that's great. Well, thanks very much. I hope everybody has a wonderful weekend, and I'll pass back to Vida. Cheers.
Thank you. So summing up, AIS Data has many usages, and you've just heard a practical example of building vessel models with AIS Data that exactEarth provides. Thanks for our audience for so many scientific and serious questions. And we have a number of webinars lined up in December on our website. Digital Ship is signing off. Take care. Bye.
Bye-bye.
Cheers, guys. Have a good weekend.
A good